Hello everyone, welcome to another session with me, Varun on Tech Tablet. In this video, we will be talking about multiple linear regression. This is the same thing that we talked about in the last video also, but in this video, we are going one step further and we'll see how a multiple linear regression model can be worked on. We'll include different parameters, we'll include different metrics. We'll see how the dataset plays a very important role in your decision making towards which model should be chosen to work on. And having said all this, we would also be considering a bit of a complex data set this time. This time, we are not creating a data set, rather, we are actually taking a data set, we are reading a CSV model, and we would be working on the same. So, without wasting any time, let us quickly go into talking about multiple linear regression. So, the tool that we are working on is Jupyter Notebook, and within Jupyter Notebook, I'm using Python. And the first two parts of the code, as you can see, are primarily dedicated towards reading the dataset and importing the libraries needed. So here I have pandas, I have NumPy, and then from my sklearn model, I'm using my model selection parameter. I'm using my preprocessor. I'm using a linear model and matrix, right? And here are the different matrix that I would be using or that I would be working on. We have R squared, we have mean MSE, mean squared error, we have MAE, mean absolute error, we have median absolute error, we have MAPE, which is mean absolute percentage error, and then we have max error. So these are the different metrics we would be considering. To begin with, I am reading the data set, which is my entertainment data set. And this data set has columns of different genre, different data types. Like you can see, we have movie ID, the name, the budget. This is in millions, the revenue in million, which is what is the budget of the movie and how much revenue is it generating. Then we have the critic score, the user score. Is this a franchise? Is this movie a franchise or not? Does this belong to comedy genre or a horror genre? Different types of genre, and then the release month followed by the runtime minutes. By the look of it, you might have had an idea that probably 1, 2, 3, 4 columns are not needed, or 1, 2, 7, 8 columns are not needed. Now, what we'll do is we'll go one step further and we'll understand what is the problem statement in the first place. So here, the goal would be to develop a predictive model, that is machine learning, which estimates a movie's revenue in millions. And to do that, it would be using pre-release attributes like budget, critic score, we have user score, and whether the movie is a part of franchise or not. So these are the columns that we would be considering to work on an MLR, which is a multiple linear regression model right now. So this is our problem statement. So firstly, let me check the head and the basic information of the column. So here you see we have that it's a data frame. We have different columns listed. You can see that we have 50 missing values in each of these columns. And here you have the names, the top 5 values that are needed for you to just take a basic glance at. Now comes the actual part, which is the game begins. We would be working on data cleaning first. So to do that, I'm importing my model, and now that my model has been imported, I would be choosing a few values that I need, and I would be pushing it into a new variable. So I'm ignoring the values which are not needed for my problem statement right now. And within my data frame, I'm selecting these 5 values and I'm pushing them into EDADF. Now, within these values, if you can see budget in million, critic score, user score, and revenue in million are numbers. So I just want to, convert them into numeric field. or convert them into a numeric data type, then I would be dropping the values which are not needed, wherever there's a missing value. And I would also be changing the data type of is franchise into integer. And now I would be checking the correlation matrix just to see how strong or how weak it is. Usually, when you're working on a model, this heat map should be able to tell you if this model is useful or not. Now, if you actually believe that you know machine learning, or if you have an idea of machine learning, why don't you quickly take a pause, go to the comment section, and try to tell me which, or probably put it in the chat box as to which is a strongly related versus which is a weakly related, excuse me, column. So this can be done here. So now I'm also checking the data types, as you can see. So now in the next step, I would be seeing which of these values is skewed and to which extent are they skewed. Now, before you work on any machine learning algorithm, or before you've decided to work on any machine learning algorithm, I think the first goal is to see for inconsistencies. It could be null values, or it could be skew, or it could be standardization, or it could be uh, adding new variables through calculations, or it could be anything. Now, given any of these, um, you know, uh, features, or given any of these, data cleaning steps, I think it is the primary job of a developer to work on these first. So I have already done the basic part. Now I would be checking for skew if there is any, and I see that we have a good skew for budget in million and revenue in million. So we see a skew is visible. So now my goal is to work on each of these columns. Now that I have an understanding, I would be working on each of these columns. I would be cleaning each of them appropriately, and I would be pushing them into a final value. So firstly, I'm checking the initial shape, which is 1000 cross 12, which is 1000 rows and 12 columns. Now, within this data set, I would, try to push these four values into numeric column, because at the end of the day, each of these column is a number. So I would prefer them to be in numeric denominator, in numeric data type. Then I am dropping the missing values, and these missing values are pushed into df clean, right? Now, in the next step, I'm writing a small function. This function is to remove the outliers that fall within the range of, the quartiles. And here I have Q1 and Q3, which are the two quantiles, and I have written the measure for them. And in the return value, I am writing an exclusion for those values which fall above or below the set um, uh, the set values defined by IQR, which is Q3 minus Q1, right? Now, I would be applying this specific function to these columns to eliminate any kind of outliers, if any. Then I would be checking the shape again. So we have removed the outliers, we have dropped missing values, and we have converted all the columns to numeric to maintain a standard data set. Now, in the next step, I would be checking the shape of the cleaned data set. And here it is 796 by 12. So we see how we have around 200 odd columns, which are rows which have been eliminated because of different, could be outliers, or could be missing values. Then I'm also checking the skew, and we see that the skew is now gone. So skew is also not a problem, which means that this data set is now good enough to be applied to a machine learning model. Now I'm splitting the data into X and Y, where these are the independent features and Y would be my dependent value. So it means that I'm trying to calculate if or how the revenue in million is dependent on budget, critic score, user score, and if it's a franchise or not. And to that, I'm splitting the data set into 20 by 80. So the test data set would be having 20% of my data, while I would be training 80% of the model to my machine learning algorithm. After which I would be standardizing the data set. Again, this standardization would be only applied to the values that we've considered. Now, why do we have to standardize? If you have noticed the data set in the first instant, we see that we have columns which are in tens, we have columns which are in hundreds, we have columns which are only in units. So to avoid any kind of numeric collision or to keep the system easy, we are trying to standardize here. And once you standardize, you see how all values fall within a set range. Now, after I've standardized, in the next step, I would be transforming the data and I would be fitting it to both my train and test values. Then comes the last part, and in this part, we would be, trying to import different models. We would, at the same time, we would also be trying to import different metrics that are required for us to understand how a linear regression model is working. So to that, I'm importing a few libraries. Again, it is not necessary that we import libraries in every line. I've just done this to have the visual clarity needed for anyone who's trying to learn the video. So you have to create a function which goes by the name evaluate model. And within this, I would be, predicting the values on test for all obvious reasons. And in the return parameter, I have my R squared. I have my RMSE, which is root mean squared error. I have MAE, which is my mean absolute error. And I have my MAPE, which is mean absolute percentage error. And I am trying to work on 5 models here. The first one is linear regression, ridge regression, lasso regression, random forest, and gradient boosting. These are the 5 machine learning models that I'm working on in one single take. Again, I'm trying to work on different models to see how or which of the models is performing better. Now, again, I would really appreciate if you could quickly pause here and take a guess based on your understanding as to which of these models would perform better and why. And then once you have posted your comment, you can probably cross-check it with the final answer that we have. Okay, in this step, in this specific, I am using linear regression with all the standard predefined parameters. Then I'm going with ridge regression with an alpha of 1.0, lasso with an alpha of 0.1, random forest regressor with 100 trees, gradient boosting regressor again with 100 trees, and a learning rate of 0.1. Random state is completely optional. You may either choose to consider that parameter or probably remove it. However, I would recommend you to change different values of random state and remove the value random state and see how your model behavior performance is changing. Now that this model and the function have been considered, here it is time for us to write a very small loop that would fit the model into the models and that would run the function on the specific model. After doing this, we have R squared, RMSE, MAE, and MAPE for lasso regression, ridge regression, linear regression, random forest, and gradient boosting. We see how R squared values, RMSE, MA, and MAP are almost very close to each other. And this very clearly tells us that none of these models are able to predict the end predictor nicely, or none of these are strong enough predictors of the revenue, which is supposed to be our dependent column. So here you see R squared values are at an all-time low and they're actually at negative, which is a very big red flag. Then we see how The model explainability does not change for any of these models. We see how RMSE, MAE, and also MAPE do not have major changes, which means we do not see a lot of explanation as to how each of these models is performing. So the final takeaway here is, it is not enough for you if you have just considered three or four models, and if you have a low RMSE and you have a good R squared value. It is also important to consider other error metrics, or other metrics which talk about the different factors towards considering a model. Also, in the comment section, do not forget to mention what, according to you, if you were a data scientist, what, according to you, would be the best step forward for us to resolve this problem and take this further. Please post it in the comment section below, and I would really try to respond to any of those comments, which is the best model, and I would also try to make a video out of it. In the next learning video, we would be looking on a linear regression model, but we would be working on model enhancement, wherein we would be trying to focus on how a model can be worked on towards betterment, assuming and considering the data set is a good fit for linear regression, and it can be used for a regression model, right? Till then, do not forget to watch the first part of the video if you haven't. And also, if you are a music enthusiast, do not forget to check out my other channel, which is Hyderabadi Chora, on YouTube and Instagram. You all have a good day out there. Thank you very much.